This is Mission Control Houston. We want to welcome you to today's Space Station Live. It is Friday, August 30th, 2013. This is a live view inside the International Space Station Flight Control Room here at the Johnson Space Center in Houston, Texas. Right now on board the International Space Station, Expedition 36 is busy. It's under the command of Pavel Vinogradov. He is there in the center left of the screen. Back behind him is Alexander Mazurkin. Back there at the back middle is NASA astronaut Chris Cassidy. Beside him is Luca Parmitano from the European Space Agency, and in the front is Fyodor Yurchikhin, and on the far right is Karen Nyberg. The big news of today is that the crew, specifically Chris Cassidy, Karen Nyberg, and Luca Parmitano, getting ready for some activities tomorrow. They're going to be taking a look at this leaky spacesuit that affected Luca Parmitano back during his spacewalk with Chris Cassidy on July 16th. As most people know by now, there was some water that began leaking into Luca's helmet during that spacewalk. So since that time, the ground teams and the crew have been doing some investigation and some engineering work to examine what could have caused that leak. They do have some suspects. And here we're taking a look at some work that Chris Cassidy did earlier this week to test out the suit. You see some of the water that is inside the helmet. That is because basically what they did was power on the suit as if it were about to go back out the door, and to verify that the leak was still there, and obviously it is. So what they will do tomorrow is to swap out a water relief valve, and they will also change out what is known as the gas trap. Those two are really not related specifically inside the suit. They are part of the plumbing, for lack of a better word, that is part of the life support system on the spacesuit. The water relief valve is suspect. The gas trap, the reason they're doing that is because it is easy to get to. It could be brought back home if they want to, so they can take a water sample to see if there's any sort of contamination inside the suit itself. And the easiest way to explain it is that the gas trap itself sits further upstream from the water relief valve and has a filter on it that's sort of a finer filter than what the water relief valve actually has on it. So if there's any sort of contaminant or any sort of particulate matter inside the water loop inside the spacesuit, it would be caught by that gas trap and its finer screen before it got to the water relief valve. So the thought is go ahead and change it out since it's easy to do, and they'll be taking a look at that as well. In between those two steps, after they finish up the water relief valve, they will turn on the suit just like they did earlier this week to check out and see if that solved the problem, and then they will proceed to swap out that gas trap valve in sort of a three-step fashion tomorrow. Of course, we're not going to be on the air on Monday since it is a federal holiday, but we will have an update for you first thing Tuesday morning as part of Space Station Live at 10 a.m. Central Time, 11 a.m. Eastern Time, and give you an update on this weekend's activities. Cassidy and Vinogradov and Mazurkin also busy just in the last few minutes wrapping up a leak check of their Sokol launch and entry suits. These are the suits that they wore whenever they launched to the space station back in March. They will put them back on coming up in a few days. On September 10th, as they get ready to come back home, this crew is beginning to wrap up their time aboard the space station. They've been going through some departure preps this week, just basically packing up their items that are coming home. And then they've been checking out their suits today and communicating with the Russian ground team just outside of Moscow. We will, of course, have live coverage here on NASA television as these landing events occur. All of these times you see here are in Central Time at 3 o'clock on Tuesday afternoon, September the 10th. We'll have hatch closure coverage as the crews say farewell to one another, as Cassidy, Mazurkin, and Vinogradov get ready to come home and leave behind Nyberg, Parmitano, and Yurchikhin. Hatch closure is just a few minutes after we come on the air at 3:19 p.m. Central Time. We'll be back with our second broadcast at 6:15 p.m. Central Time for the actual undocking of their Soyuz vehicle as it backs away from the station. That undocking will take place at 6:37 p.m. Central Time. And then we will return for our third and final broadcast at 8:45 p.m. Central Time. That will take us to the landing a little more than an hour later at 9:58 p.m. Central Time. And then soon after that, we'll have the post-landing video file here on NASA television at 11:30 p.m. Central Time with the highlights of the evening's activities. And we'll also be sending you an interview with NASA astronaut Chris Cassidy as well. So again, all that coming up on September 10th. Also right now, as we look live on board the space station HTV, this Japanese cargo vehicle getting ready to wrap up its mission to the International Space Station. All of the Cargo operations have pretty much been wrapped up. Everything's been done in terms of the internal cargo. HTV is now packed full of trash and other items that the crew doesn't need anymore, so those are going to be destroyed at the end of HTV's mission. If you look very carefully in the center of HTV, you can see that this external pallet that brought up some unpressurized cargo to the station has been returned to HTV. There is a Defense Department experiment that is now installed on that is no longer needed. It's going to be destroyed as well. So just earlier this morning, the ground teams did command the station's robotic arm, which you see there mounted onto the Harmony node, to slide that tray back into HTV, and then it was released. And right before we came on the air, the flight director here today, Ed Van Cise, gave his robotics controllers the go to begin the process of actually grappling HTV. So that will secure this cargo vehicle to the station's arm one final time. And then coming up on September the 4th, as we go off the air for Space Station Live, but we will continue with our live coverage, HTV will be removed from the station right at the top of the hour, and about a minute later it will fire its engines, begin the process of backing off from the station, and it will say farewell, its mission coming to a close. It will be deorbited coming up on September the 7th. While all of this is taking place inside the station, the Russians are working on a variety of different experiments on their end of the station. The Matryoshka experiment is being tended to today. This is one of the radiation experiments on board that basically involves the crew setting up some dosimeters or basically radiation detectors throughout the station. There's even a mannequin that they use that resembles a human. But they set these up. It monitors the radiation levels on board the space station, and then that data is downlinked to the ground teams just so they can check and see how the environment is doing on board. Luca Parmitano and Karen Nyberg are busy today working on what is known as the Ocular Health experiment. This is one of the newer human research experiments on board because, as we've talked about before, there's been a sort of a newer phenomenon noticed with the crew members that certain crew members can have their eyes affected whenever they come back to Earth and actually lose almost 2.5 diopters of vision, which anybody that wears contact lenses or glasses knows exactly what that means. But it's a fairly significant impact to the astronaut's vision. And then the ground teams and the scientists are trying to figure out exactly what causes that and what the common thread is in order to predict it, to see if there's any way to mitigate it. So what they're doing is having the crews on board use the ultrasound to examine their eyes. There's a thing called a fundoscope. You see Karen Nyberg there beginning to work with this device. That laptop device that you see there, that actually is the ultrasound on board the space station, which, of course, one of the important things about the space station is that it teaches us how to miniaturize things that would take up large spaces in doctors' offices and hospitals. Obviously, you can't have that. Things like an MRI, you can't fly those sort of things on board the space station. So it sort of forces us to find ways to miniaturize these things and make them much smaller. So that ultrasound you see there is used for a variety of different experiments, including this ocular health experiment that they're working on today. They're also going to be taking some blood pressure measurements and some other data points that are part of this ongoing experiment. Nyberg is also busy today working on an Asian seed experiment. This is a plant experiment that is on board, taking a look at how different plants grow in orbit. That teaches us a few different things. It teaches us about not only plants here on Earth and what makes them behave, but also teaches us whenever we look to go further beyond low Earth orbit and go to an asteroid and onto Mars one of these days, it would be helpful if you didn't have to pack all your food, if you could actually grow it on board. So it's important for them to understand exactly how plants behave, what makes them grow, what makes them flourish, so that hopefully one of these days they can have entire gardens up there with all sorts of things that they can grow for their food. This is Nyberg working inside the Kibo laboratory. Earlier today, this is the home of that Asian seed experiment. She's also been busy in there today working on something called Spheres that took place earlier this week, the Spheres Rings experiment. We've talked about Spheres for quite a bit here on NASA television throughout the months and all these expeditions. There's a new version of it on board, and what she's been doing is putting that experiment together. What it does is take a look at how different satellites could fly in formation. This specific version of this investigation is looking at how power transfers could actually happen between two satellites without them actually touching, which is pretty revolutionary whenever you think about it. There are the two Spheres rings that we were talking about inside Kibo earlier. If you've watched us here on NASA TV, you know what the Spheres devices look like. They look like something out of a Hollywood movie. The Spheres rings is pretty much exactly like what it sounds like. It puts a big ring around it, and then Karen was running that experiment earlier this week.
Is it responding?
Нет.
No, nothing is responding.
Правая.
On the right side, it's all red.
As we were talking about, HTV is getting ready to end its mission aboard the space station. There, standing up in the blue shirt, is Ed Van Cise. He is today's flight director on console. And the maroon shirt back behind him is Gary Horlocker. He's actually the lead flight director for Expedition 36. Sitting beside them in the chair is Jack Fisher. He is today's Capcom. You see the HTV model there on the flight director's console. Anytime we've got a visiting vehicle up on board the space station, the flight directors do like to put a symbol of the vehicle up on their console. He actually, while we were talking about Karen working on board the space station, actually did go ahead and put the exposed pallet back inside his version of HTV. Of course, the much larger version up in space also has its exposed pallet back inside. But, you know, we are NASA, and they like to keep things fairly specific and exact and representative around here. So both HTV on the ground and up in space are now in the proper configuration, getting ready for the end of this mission coming up on September the 4th. As we talked about, we will have sort of an expanded Space Station Live coming up on that day, on the 4th, because HTV is going to be released shortly after we would typically go off the air. So we're just going to stay on live and carry all of the activities on that day. And then once HTV gets on its way, after 11 o'clock a.m. Central Time, 12 noon, we will part ways with it, and then on September the 7th, that is when HTV will be burned up in the atmosphere, and its mission will be completed.
7 went by, mostly 1 millisecond to 4 milliseconds. Order, go back. Return the cable to 616 back to its previous location.
Here's a view looking down the station's robotic arm. You're looking at the target on HTV, as we talked about right before we got on the air. Ed Van Cise, the flight director, did give the robo team, the robotics team here in Mission Control, the go to begin the process of grappling HTV, or securing the station's arm onto the vehicle itself. So that should take place coming up here shortly. Of course, if there's movement while we're on the air, we'll show you the view live.
Так, я вот воткнул
616. And the right on top, 616 is blinking. Green, yellow. So what should we do now? Shut down and restart? No. What is it now? Is it the same? Running? Replay? 4 milliseconds, 111. It's working continuously. 2 milliseconds. 7 milliseconds. Mostly it's 1. Yes, go ahead. Order. Window 2, let's relaunch LS1. Order. Can you ask Sasha to talk to us? We really need to talk to him very quickly. Okay, I will try.
please close the lab window shutter now.
This is station Luca on 2, the shutter is closed.
We copy. Thanks, Luca.
Lesson Bakabakava, have you completed it or not? If you have not completed it, then you don't need to. If you have completed it, then what's done is done. Well, we were in the vehicle for now, so let me check into that. Okay, thank you. Okay, and I'm continuing my operation. Fyodor, overall, we understand what the picture is. LS responded. Did LS respond? No, time out. Okay. Item 8 completed. Continue working for the radiogram. Activate device control. Switch everything over. When you get to item 10, and there is a request there to perform additional steps. Okay. Okay, let me complete 9. And RSS 2, while developing masters. And cables, return. When you started returning cables, RSS 1. And 616, let it be in its own location. 613, return it to its nominal location.
Так,
613, returning to 613. 613. Okay, 613. 616. 616. 616.
А 615 я кабеля не вижу. Сейчас посмотрим.
I don't see the other cable. 613 is in the nominal configuration. 616 in the nominal configuration.
616 на место, 613 на место и 62 возвращаем на место, да?
А 6.2 там, Е2 там было пустое гнездо.
6.2 and E2 was empty at the bottom. Yes, 6. Yes, 6.2.
6.2 в 6.1. 6.1 воткнули.
Да.
Поэтому 6.2 возвращаем на свое место.
Okay, 6.2 back to its nominal location.
Все, кабель 6.2 на своем месте, 6.13 на своем, 6.16
okay, 6.16 in its nominal location.
Хорошо. Итак, 9. А вы сделали уже 9 вот в начале этот?
Did you?
Нет, еще.
Do number 9. Executing step 9.
И в окошечке change log.
And in the window, change log text.
Значит, IP-адрес прежний 10.
The IP address is the same, 10.1, 10.1. Okay, copy.
This is Mission Control Houston. While the crew has been busy on board the space station this week with quite a bit of robotic activities with HTV and also some experiment work, they've also been getting ready for the upcoming arrival of the Orbital Sciences Cygnus vehicle. Now, Cygnus is the second of the two vehicles that have been developed under NASA's Commercial Orbital Transportation Services Program, or COTS. SpaceX tested out its spacecraft here a couple of years ago and began flying regular missions last year. Now Orbital Sciences will begin flying as well. Now SpaceX started COTS back in 2006. Orbital Sciences came along in 2008, a couple of years later. So now it is focused on doing a demonstration flight coming up beginning on September the 17th. That is when it is targeted to launch from the Wallops Flight Facility up in Virginia. If it is able to launch on that day and all goes according to plan, Cygnus should arrive at the station on September the 22nd. So the crew's been getting ready for that. They've been packing a bunch of items and trash that will be put inside Cygnus at the end of its mission. Cygnus is bringing up about 1,300 pounds of supplies to the space station. So while we have a moment now, we're going to take a look at this mission and Orbital Sciences itself.
With a half-century of spaceflight experience already in hand, America's space program is now pushing ahead on parallel paths, revolutionary and complementary paths. On one, NASA is building a space launch system and Orion spacecraft to carry astronauts farther from Earth than we've ever gone before, to an asteroid and eventually to Mars. On the other path, NASA is leaning on American-based private companies to help supply our orbiting laboratory, the International Space Station. As the Space Shuttle era came to a close, NASA knew it needed help to supply the station with tons of cargo every year and looked to the private sector.
How can we partner with industry? How can NASA be a partner with commercial industry and take advantage of the ingenuity and innovation that exists in American industry, as well as the entrepreneurial spirit to develop these new capabilities, just like any new product can be brought to market?
The answer was the Commercial Orbital Transportation Services Program. Rather than NASA deciding on a spacecraft design down to the nuts and bolts, it made seed money available to private industry to develop their own cargo ships that could carry supplies to the space station, where human crews have been working for more than a dozen years. California-based SpaceX won its COTS agreement in 2006. Its Dragon spacecraft successfully performed a test flight in May 2012 and completed its first fully operational mission late in the year. SpaceX flights continue each year, taking tons of supplies and science up to the station, and just as importantly, returning science experiments back to Earth for study. Now, Virginia-based Orbital Sciences Corporation, which won its COTS agreement in 2008, is about to join the club with its Cygnus spacecraft. After Orbital performs a Cygnus test flight to the station, it too will begin flying routine delivery flights to the orbiting complex.
That will be the final milestone in what we call the Commercial Orbital Transportation System Space Act Agreement that will allow us to transition from that phase of the program into an actual contract with NASA to deliver cargo over 8 missions in about 4 years to the International Space Station.
Cygnus rides to orbit on the Antares, a 2-stage launch vehicle designed to provide reliable access to low Earth orbit for payloads of more than 5,000 kilograms. Its design incorporates components from leading global suppliers and uses subsystems that are already deployed successfully on Orbital's other rockets, the Pegasus, Taurus, and Minotaur launch vehicles that have been flying for years.
But Antares will serve a much broader market than just the space station logistics functions. It will also be used by civil and national security customers in the governmental market, as well as commercial satellite operators.
The Cygnus Advanced Maneuvering Spacecraft, consisting of a service module and a pressurized cargo module, also incorporates elements from flight-proven systems flown by Orbital and its partners. The service module avionics systems are from Orbital's LeoStar and GeoStar satellite lines. The propulsion and solar power systems from the GeoStar communications satellites. The pressurized cargo module is based on the multi-purpose logistics module by Thales Alenia Space, which built the cargo modules that carried supplies to the station 11 times, riding in the payload bay of the space shuttles. With a pressurized volume of nearly 19 cubic meters, Cygnus can deliver a total cargo mass of 2,000 kilograms.
Without the ability to take cargo, you won't be able to keep the station operating as a viable research platform, or even keep the crew there and keep them fed and clothed and all the things that anybody on an outpost would need. And that's really where they are, is on an outpost. So having that lifeline to Earth is very, very important.
Orbital will launch the Antares rocket and Cygnus cargo craft from NASA's Wallops Flight Facility in Virginia, thus opening a new commercial spaceport and strengthening the American commercial launch industry's role in the new future of spaceflight. As SpaceX and Orbital ramp up their supply flights, the International Space Station will continue to serve as our home in space and the site of the scientific discoveries that will allow humankind to venture beyond low Earth orbit, to explore farther from Earth than we've ever been before.
So that was a look at the upcoming Orbital Sciences mission as it gets ready to fly its Cygnus cargo vehicle up to the International Space Station coming up in September. Again, launch is scheduled for around 10:16 a.m. Central Time, 11:16 a.m. Eastern Time on September the 17th. If all goes according to plan and Orbital's able to lift off on time, that should lead to a rendezvous and docking with the International Space Station coming up on September the 22nd.
Well, you'll have the alarm. It's up to you, because otherwise you'll have the alarm going off and you'll run out of water. So it's up to you when you're going to get it done. Okay. We'll think of something and cook up something. Okay. Thank you. Sasha, thank you for the reminder. Otherwise, we would be dying of thirst, like as if we were in the desert. Okay. Well, as soon as you take a look, you let us know. Okay, go ahead. Thank you. Okay, talk to you later.
As we mentioned at the top of the hour, Chris Cassidy and Alexander Mazurkin and Pavel Vinogradov wrapping up some tests, some leak checks of their Sokol launch and entry suits earlier this morning as they get ready to come back home the evening of September the 10th. We want to take a look at our programming for that day real quickly.
restarted the first one.
They're going to be undocking from the International Space Station coming up on the afternoon and evening of September the 10th. And, of course, we'll have live coverage here on NASA television beginning at 3 p.m. Central Time, with the hatch closure actually having taken place at 3:19 p.m. Central Time. Undocking will take place at 6:15. Our coverage will begin at that point, undocking at 6:37 p.m. Central Time. Our landing coverage begins at 8:45 p.m. Central, with landing at 9:58. And then we'll have a post-landing video file coming up at 11:30 p.m. Central Time that evening. While we have a quiet moment here inside Mission Control, we're going to take a look at these three crew members, as well as their fellow crew members, Karen Nyberg, Luca Parmitano, and Fyodor Yurchikhin.
The members of the International Space Station crew all believe that their 6-month mission is an important part of the work that's needed to help human beings continue to explore well beyond their home planet. Pavel Vinogradov was born in the far eastern Russian town of Magadan and grew up in the even farther eastern town of Anodir, just 500 miles across the Bering Sea from Nome, Alaska.
If you have been to Alaska, then it's pretty much the same. The nature is just fantastic. Of course, the climate is very harsh, 8 months of winter, lots of snow and ice, but I love it. I enjoy it.
After a childhood spent dreaming of becoming a pilot, Vinogradov left Anodir after high school for the Moscow Aviation Institute. He earned a degree in rocket booster design, then taught and did research at the institute while earning a second degree in computer systems and systems analysis. Vinogradov joined the design bureau of the Rocket Space Corporation Energia in 1983 and worked on the Mir space station, the Buran shuttle, and other Energia vehicles before being selected to Energia's Cosmonaut Corps in 1992. He logged 198 days in space as the board engineer on Mir 24 and made 5 spacewalks to repair Mir after a Progress freighter punched a hole in it in the summer of 1997. He made one more spacewalk in 2006 as commander of the International Space Station's Expedition 13, a 183-day mission that restored the station's crew complement to 3. He believes today's space exploration efforts bear comparison to the sea voyages of the great explorers in the Age of Discovery.
People who were exploring the Earth did not know that they will discover America in 4 months, for example. The risks were great. But I have no doubt that likewise, we, as those explorers, we need to explore space.
Retired Russian Air Force Lieutenant Colonel Alexander Mazurkin is a product of Western Russia, born in Yurshichy in the Smolensk region and raised a couple of 100 miles away in Oryol. He calls his childhood a typical one and says even as a young boy, he wanted to go places no one had been to before.
I wanted and decided to be a cosmonaut when I was a little boy. When I was a 13 years old guy, I went to the aviation club. There I made parachute jumping. There I was flying on gliders.
Becoming a pilot was next on his list. After school in Oryol, Mazurkin went to the Kasha High Air Force Pilot School in Volgograd, then finished his pilot training at the Armavir Military Aviation Institute in Krasnodar in southern Russia. He spent the next 7 years in the Russian Air Force as a pilot instructor at the Krasnodar Military Aviation Institute before being selected as a cosmonaut in 2006. Mazurkin shares the philosophical view of the Russian rocket science pioneer Konstantin Tsiolkovsky, who believed that Earth is the cradle of humanity, but that mankind can't stay in the cradle forever.
He was positive that we are going to the space and we will live in in other worlds, in other different places, and the time will come in for this, I'm sure. That is why I think we should do this job.
U.S. Navy Commander Chris Cassidy is a native of Salem, Massachusetts, who grew up in York, Maine, on the Atlantic coast. He was aware of the space program as a young boy, but admits he wasn't particularly interested.
I was just like every other boy. mowed lawns, had a couple odd jobs in restaurants and things in the summertime, but that was all to really pay my gas to drive to the basketball court.
Cassidy left York after high school, first for a year at the Naval Academy Prep School, and then on to Annapolis, where he earned a bachelor's in mathematics. Next stop was San Diego to begin training in special operations as a Navy SEAL. After 4 years stationed in Virginia, he earned a master's in ocean engineering at MIT. And about that time, he became aware of a fellow Navy SEAL who'd had a similar career arc to his, astronaut Bill Shepard.
So one day I actually met him or called him, and he gave me some great information, and I thought, you know what, that sounds really like a really fun job. I think I'd like to do that. So I was probably 26 or 27 when the idea first popped into my head.
Cassidy applied, but didn't get the call from NASA. The next year, just weeks after September 11th, the SEAL platoon he commanded did get the call, and he was deployed to the Afghanistan region before the 1st of October. He returned home to another posting in Virginia, and he was selected for the astronaut program in 2004, just days after coming home from a second deployment to Afghanistan. Cassidy made 3 spacewalks on his first trip to the International Space Station, on the 2009 Space Shuttle mission that delivered the components to complete construction of the Kibo Laboratory Complex. He's enthusiastic about his part in laying the groundwork for some future generation of Earthlings to fulfill their destiny, to find a new home in space.
But there'll be a time when there'll be people living on other planets. And it's the work, the hard work that we're doing right now, all of us across the globe, that are going to set the stage for that type of environment. Just like Christopher Columbus set sail one day across the ocean. And thanks to those great explorers, we live the life that we do today.
Fyodor Yurchikhin was born and raised in the Black Sea port city of Batumi in Soviet Georgia, growing up in a time and place where all the children wanted to be cosmonauts, where the winners of kids' games were called Gagarins. Yurchikhin wanted to be a part of that life, even if he couldn't be a dashing test pilot.
For what reason I understood maybe in this time, then it's maybe in my health, it's not enough to be a cosmonaut, but what is more important for me, be a pilot or be an engineer in space program? Of course, the space program, it was too important for me.
So, after high school, Yurchikhin went to the Moscow Aviation Institute, earned a bachelor's degree in mechanical engineering, specializing in aerospace vehicles, and went straight to work for the Rocket Space Corporation Energia as an engineer. He worked as a flight controller, and when he became lead engineer for the Mir shuttle program, he spent time at NASA's Johnson Space Center supporting that effort. Yurchikhin was selected as an Energia cosmonaut in 1997 and earned a PhD in economics at Moscow Service State University while preparing for his first spaceflight. He was a member of the STS-112 crew that delivered a piece of the station's starboard truss during Expedition 5 in 2002. He returned 5 years later on a Soyuz spacecraft as commander of Expedition 15 and made 3 spacewalks, and followed that with 2 more EVAs as a station flight engineer on Expeditions 24 and 25 in 2010. He believes the station program is paying off in the things we're learning while making the effort, from improving the spacecraft themselves to the tools we develop.
But the first big, exactly great sensor for digital camera, it was factored for this program. And now it's usual for everybody. It's usual for my daughters. It's usual for young boys and girls. I know my profession, it's very important for human. Why I am on this road.
Italian Air Force Major Luca Parmitano is from Sicily, born in Paterno and raised in Catania in the shadow of Mount Etna. Although he was very young when he saw the first space shuttles fly on television, he was captivated by the idea of what those images represented.
So I remember seeing the first astronauts floating around the space shuttle doing their job. And I think that even in a kid, as small as I was, I just thought that must be the greatest job in the world to be able to do those things and call it a living. So since then, I had this dream of becoming an astronaut.
Parmitano won a scholarship to spend a year of high school in Southern California. In that year in America, he not only intensified his desire to be a pilot by living with a host family in which the father was a marine navigator, but he met the girl who years later would become his wife. Back in Italy, Parmitano earned a bachelor's degree in political sciences at the University of Naples and graduated from Italy's Air Force Academy, then completed his basic training at the Euro-NATO Joint Jet Pilot Training Program at Sheppard Air Force Base in Texas. After 6 years with a fighter squadron in Italy, he was sent to France to train as a test pilot and earned a master's in experimental flight test engineering at the Superior Institute of Aeronautics and Space in Toulouse in 2009, the same year he was selected for astronaut training by the European Space Agency. Now he's making his childhood dream a reality and fulfilling a desire to push the boundaries of human knowledge.
That's who we are. That's what makes us humans. That is what makes us different from the rest of the animal kingdom. And if we don't follow our nature of being explorators, of being thinkers, then we are denying a part of ourselves that is incredibly important.
Dr. Karen Nyberg was part of a big family growing up in the tiny town of Vining, Minnesota. And from the time she was a very young girl, she knew she wanted to be an astronaut, although she doesn't know why. She learned some solitary pursuits as a little girl.
I've been sewing. My mom taught me to sew when I was probably 5 or 6 years old. I've been drawing since I was also that age. I would never sit in front of the television just sitting there watching TV. I always had a piece of paper and a pencil and was drawing or doodling or doing something.
But she took advantage of being in a small town to join more school activities than most kids in big city schools join.
I was on the basketball team, the volleyball team, the track team. I took stats for the baseball team. I was in the choir. I was in the band. I was in the drama club. I was able to participate in all of them, learn to be a team member.
She went to the University of North Dakota to study engineering and learned about a program that lets students work at NASA's Johnson Space Center in Houston. Nyberg worked as a co-op in Houston while finishing her bachelor's in mechanical engineering in Grand Forks and while starting her graduate work at the University of Texas at Austin. After she finished a master's and a doctorate in mechanical engineering in Austin, she returned to JSC, working full-time in the Crew and Thermal Systems Division for 2 years before she was picked for the astronaut program in 2000, where she met her future husband, fellow astronaut candidate Doug Hurley. Nyberg was part of the STS-124 space shuttle crew that delivered the Kibo laboratory module and Japanese robotic arm to the International Space Station in 2008 and was the first person to ever operate the shuttle robotic arm, the main station arm, and the Japanese arm. She's confident this mission will appeal to the adventure seeker in today's kids.
I think a lot of it is based just on human nature, that we are all very curious people. Human beings like challenges, and this is an ultimate challenge.
This is Mission Control Houston. Again, that was a look at the Expedition 36 crew. Karen Nyberg, Luca Parmitano, Fyodor Yurchikhin, as well as Chris Cassidy, Alexander Mazurkin, and Pavel Vinogradov. The latter three getting ready to come home coming up on September the 10th. So they are close to wrapping up their time aboard the International Space Station, almost 6 months. They launched back on Thursday, March 28th. They'll come home on September the 10th, so they got pretty close to the 6-month mark. But they'll be coming home aboard the Soyuz that brought them up to the International Space Station. Their Soyuz currently docked with the Poisk module. You see it up there on top. It is the Soyuz 34. Also on the station right now, the Progress 52, the ATV-4. That is the European spacecraft that brought up a lot of cargo back at the back. And then the Japanese HTV-4 cargo vehicle there on the bottom side of the U.S. segment of the International Space Station. It getting ready to wrap up its time coming up next week on September the 4th.
Thanks for sending us that info, and no luck in the Node 2, Deck 3, or Node 1, Deck 4 locations.
And you got my correction that it was 1026 instead of 1028 for the serial number? Or had you floated off by then?
No, it doesn't. I did, and it's the only CTV in there. It's 1026, so it's a no-brainer.
So no love. Okay. We'll see if we can find any place else that it might be hiding.
I will look too, but we do have a magnifying glass. It just requires a hand to hold it. So, all right, thanks.
Raj, of course you could do something like Don did, where he had that little phalange boingy thing that he strapped to his head to hold his wristwatch.
He's full of good ideas, so I'm not counting anything out that comes out recommended from Don.
Roger that. Alrighty, we'll keep looking for
Moscow ISS on Station Ground 1.
Station Houston on 2 for Chris.
Go ahead.
Hey, we're grasping at straws, but just some amplifying remarks. Don said that he thought it was in that volume, so it might not have been specifically in the C2B, or in the IVA toolkit, but kind of around there. There was no foam anywhere around those areas.
I looked in everything that in that spot. There was a Ziploc bag that had like aluminum tape and some other stuff, and I pulled apart the pieces that I couldn't see through, and it wasn't in there. There was a half CTB, and then the 1.0 that you described, and then some other kit, but it wasn't in any of those things.
Copy that. Here comes handover.
This is Mission Control Houston. Chris Cassidy aboard the space station there a few minutes ago, talking with Jack Fisher, the Capcom here. He's getting ready to continue his departure preparations aboard the International Space Station. He's also working today to gather up some trash and other items that will come home aboard the Orbital Sciences Cygnus at the end of its mission. As we've been talking about Orbital coming up to the station after it launches on September the 17th. It should arrive around September the 22nd if everything goes according to the timeline. We'll have a briefing next week on September the 4th at 3 p.m. Central Time, 4 p.m. Eastern Time, to take a look at that mission. And that briefing will be Mike Suffredini, the head of the Space Station program, as well as Alan Lindemoyer, who is the head of NASA's COTS program, as well as Frank Culbertson, who is Executive Vice President of Orbital Sciences, and Courtney McMillan, who will be the lead flight director for that mission. So again, 3 p.m. Central Time, 4 p.m. Eastern Time, here on NASA Television. It has been quite a busy week on board the International Space Station. This weekend will be busy as well for the crew of Expedition 36. Chris Cassidy, Luca Parmitano, and Karen Nyberg, half of Expedition 36, will be working on Saturday to take a look at this faulty spacesuit that Luca Parmitano had worn back on on July 16th. As you can see, Luca there making a face as the crew checked out this spacesuit earlier this week. They basically turned it back on and recreated the water leak, which you see some of the droplets there gathering in the helmet. But what they're going to be doing on Saturday is replacing a water relief valve as well as a gas trap. And in between those two steps, they will recreate what they did this week, which is basically just turn the suit back on and check it out to see how the work has progressed. The goal of this is to find the root cause for this spacesuit water leak that happened to Luca while he and Chris were outside. And then the ground teams here in Houston will be watching along this weekend, and we'll have a full report for you on Tuesday morning of how all of that work went. There's also a reboost this weekend coming up for the International Space Station. The ATV-4 that's at the back end of the Russian segment will fire its thrusters. This will be setting up for Chris Cassidy and Alexander Mazurkin and Pavel Vinogradov's departure and landing coming up on September the 10th. But that reboost will take place for about 3 minutes and 25 seconds on Saturday at 2:17 a.m. Central Time. Another cargo vehicle, the HTV, that is the Japanese cargo craft on board the International Space Station. Its operations also complete. There you see it on the bottom side of the U.S. segment. The crew worked very diligently after HTV arrived at the space station to unload all the cargo that was on the inside. There's also some external cargo that was released, and the external pallet that was in the middle of HTV was put back in earlier today. The release of the actual entire HTV-4 is coming up at 11 a.m. Central Time on Wednesday, September 4th. We'll have live coverage of that here on NASA television as HTV's mission comes to a close. Leak checks also taking place on Friday with Chris Cassidy, Pavel Vinogradov, and Alexander Mazurkin checking out their Sokol suits. These are the suits that they wore during launch and will wear during landing. Their departure preparations are continuing on board the space station as these three crew members get ready to come home. They've been packing up all of their what amounts to their luggage that will come home aboard the Soyuz coming up on September the 10th. There you see all of our landing coverage. We'll have hatch closure coverage beginning at 3 p.m. Central Time, undocking coverage beginning at 6:15 p.m. Central Time, and landing coverage coming up at 8:45 p.m. Central Time. All of this on September the 10th. The crew also getting ready for the arrival of the Orbital Sciences Cygnus vehicle. That launch scheduled for September the 17th from the Wallops Flight Facility up in Virginia. If all goes according to plan, Orbital should arrive up at the station on September the 22nd for a rendezvous and docking as this Orbital Cygnus vehicle performs a test demonstration mission to check out its systems. And if all goes well, Orbital should be flying some routine cargo flights just like SpaceX Technologies did beginning last year. We'll have a briefing coming up on Wednesday, September the 4th at 3 p.m. Central Time, 4 p.m. Eastern Time to take a look at this entire mission and also the conclusion of NASA's COTS program. COTS is what both SpaceX and Orbital Sciences have participated in to build these two cargo vehicles. And that briefing will be Mike Suffredini, the head of the space station program, Alan Lindemoyer, the head of the NASA COTS program, as well as Frank Culbertson, former astronaut who is now executive vice president of Orbital Sciences, as well as Courtney McMillan, who will be the NASA lead flight director for that mission. Again, that'll take place on Wednesday at 3 p.m. Central Time here on NASA television. This week has also had a ton of science going on board the space station. Karen Nyberg worked with the Spheres Rings experiment. If you've watched NASA TV and seen the Spheres experiment, you'll notice this looks a little bit different. This experiment, which is out of the University of Maryland and DARPA, takes a look at formation flying of mini satellites and also some power transfer. The thought is that these two satellites could transfer power between each other from very, very small distances without actually touching. So Karen Nyberg and Luca Parmitano worked on that this week. Parmitano also worked on something called In Space 3. This takes a look at what are known as colloids. These are small particles that reside inside liquids. And the important thing about running these experiments up in space is that the sediment doesn't fall out like it would here on Earth. So you can imagine something that's got a bunch of particles inside a liquid. Those things would settle at the bottom because of gravity. So for scientists to study them in their natural state, they fly them up in space where there is no gravity. Now what these colloids can do is actually change the property of the liquid whenever a magnetic field is applied to it, so that liquid all of a sudden becomes a solid. This has direct impacts to life here on Earth because it could lead to better braking systems and also better buildings and bridges, because you could use these things to help buildings and bridges weather an earthquake. So that is what that experiment means for life here on Earth and also life in space. Luca Parmitano also working on some BioLab troubleshooting. BioLab is a biological rack that is inside the Columbus laboratory. One of the microscopes inside that rack was having some issues, so he performed some work on that to get that rack up and running again. Chris Cassidy worked this week with Robonaut. That is the robot that's on board the space station. They performed some checkout maneuvers of that. Chris Cassidy also put on some virtual reality gear to run Robonaut through the paces himself. But these checkouts of this big robot on board the space station continue. Pavel Vinogradov and the rest of the Russian crew also worked on the lower body negative pressure experiment. What this does is have the crew put on a pair of trousers that sort of pulls the body pressure down toward their legs. It simulates what they will experience whenever they come back to Earth. Of course, up on orbit, they don't have gravity to pull the blood down, so these trousers do reenact that to study how the crew members' bodies react to that phenomenon. And finally, Chris Cassidy and Karen Nyberg working on some eye exams this week. This is part of the ocular health experiment to take a look at some phenomena that's been noticed recently, that the crew members' eyes tend to change while they're up in space. So to determine exactly what causes that, and in order to predict it, they're being put through the paces in a number of different experiments to take a look at that using an ultrasound to examine their eyes. There you see the ultrasound as Karen Nyberg worked on that today, and that activity will continue into next week. We will be off on Monday due to the federal Labor Day holiday, but we will be back on Tuesday morning at 10 a.m. Central Time, 11 a.m. Eastern Time. We'll have an update for you on this weekend's activities to repair that spacesuit to see where the crew gets. And, of course, we'll have live coverage beginning on Wednesday of the NASA Orbital Sciences Mission Overview Briefing that will occur on Wednesday at 3 p.m. Central Time here on NASA Television. We will see you back here Tuesday morning on NASA TV. This is Mission Control Houston.